Hello guys, welcome to this video, and in this particular session I'm going to be showing you how we can train a heart disease model from scratch using several machine learning models. We're going to be using two models. We'll be using the decision tree classifier and the random forest classifier, and we'll be performing hyperparameter tuning in this particular video. So I'm going to be starting from scratch. I'll jump into cargo, pick any kind of data set, then we'll perform some kind of cleaning in the data set, and yeah, we'll get started. Okay, so I'm going to start by opening my internet, and yeah, so this is it. And I'm also going to open my restaurant. um, I'm just going to close this. Okay, I'll open my VS Code. All right, so just give some time to load. Okay, all right, so now we have VS Code loaded. It's good. Okay, all right, so now we have everything loaded, and so I'm just going to go to data set here. All right, so what do I have in mind? Type 2 diabetes mellitus. Okay, all right, so there are actually several data sets here. I could just choose this, anyone. I'll go to this. Okay, and so basically I'll go back here, okay, to show you now. There's a website known as Cargo. Okay, so if you watch my previous videos, this is where you can get machine learning, and for anybody in data science, machine learning, you want to get data sets that you're going to use for training your models and all of that. Okay, so you can come to Cargo. When you click on cargo.com, it's going to give you a host of repositories. Like it's Cargo is the repository. All right, so you see I already have an account. There is anything. I could just search here, maybe blah blah blah, which kind of data set I want. So you see previously I searched for tuberculosis, video game cells, malaria, Pokemon, Indonesia fraud detection. Okay. All right. So well, we have this already, and what I'm going to do now is I'm just going to click on where I can get the zip folder. All right. I can just click on download. So automatically I've gotten my data set downloaded. All right. Okay, so this is my data set here. So I can just quietly close this. And okay, I have my VS Code opened. I'm just going to open another folder. Okay, so let's just keep everything simple, and I'm gonna call this okay, I'm just gonna create another one and just go to fresh. So I'm gonna call this my diabetes. Okay, let me just call it diabetes. Okay, and I'll select the folder. Of course, I'll save that. So that's gone. Okay, I can close this. Okay, now this is where we're going to write our code. Okay, this is what we call VS Studio Code. And the next thing I'm going to do right now is I'm going to look for that data set, and you have to bring it closer to this particular file. So maybe I could just say I want to work on diabetes .interactive Python notebook. Now this is an extension. If you're working with Jupyter Notebook, you must use IPYNB. It means interactive Python notebook. Okay, all right. So Windows A, I want to open my downloads and to drag that data set out, and I have that zip file. I'm going to unzip it, and then I'll drag out. Okay, now we have two data sets here. We have the type 1 and we have the type 2, and I'm just going to drag it out. Yes, I just basically dragged it out of that zip folder, and I think I can close it. So this is what we are going to be working with. This is a Chinese data set, kind of, I think, Shanghai. So we've got type 1, we've got type 2, and all of that. Okay, so we just want to see what this thing looks like before we take it into our data frame. Okay, it's loading. All right, so this is what a real-time data set looks like. If you're a data scientist or you're getting into machine learning, I'm sure you're definitely familiar with this. This is a data set that contains over 100 questions. If you can see that, okay? It's over 100 questions that are reported. They've got their patient number. Probably this is the file in the health facility. This is the gender. This is the age in years. This is the height. This is the weight. This is the BMI, the smoking history, and all of that. So we've got a lot of columns all in here, right? And we've also got some columns that maybe you might want to perform some kind of tokenization, but for the meantime, I think I could just quietly close this. Maybe we could just minimize that, maybe if you want to make any reference to it. So I will drag this inside here. And this is an Excel file. This is an XLSCX, XX, all right? So this is an Excel sheet. So what this means is that it's not the usual traditional comma separated file, but still we always have a way to read it. So I'm going to open my Python environment and I'm going to select my kernel, and now if you're working on this for the first time, the first thing you might want to do is to control backtick, and then you have to install some of the dependencies, maybe pip install numpy. Then you have numpy, pandas, you have scikit-learn and all of that. Maybe you've got matplotlib and all of that, okay? Now, but I'm not going to install all of this because I already have all this satisfied, okay? If I open my terminal and I go to command and right here, this is also another alternative. If you're using the Anaconda, you can type Python -- version, and it's going to show you that we're running on Python 3.14. okay? So if I do pip, for example, pip install pandas, okay, if I run that, you see that it's already satisfied. Pip install matplotlib, you see that it's already satisfied. So I have basically all the packages that I will be needing for this, all right? Okay, so I'll close my terminal. So the first thing we're going to do now is to import all the dependencies that we need for this particular project, okay? We import all the modules that are actually relevant. So I'm going to start by importing numpy as an alias of np. Then I'm going to import pandas as pd. So this is an alias that we use. I will import matplotlib from the pyplot module as plt. Then I'm going to import joblib because we'll have to save our model. So what we use this to do, and I'm going to explain now, right? So for this, I'm going to write a comment. So we use this to do what? For operations, okay? We use it for mathematical operations in Python. That's what we use the numpy for, okay? Mathematical operations. In Python, right? Now, what do we use the pandas to do? We use the pandas for what? We use it for handling our data sets. Maybe if we want to anything that relates to our data frame, we use it for cleaning, and we use it for what? For processing. Our series, our pandas series. Okay, pandas series and df. I already wrote that frame gen. Now for the matplotlib, we use it for what? Visualization. So we're going to be performing some visualization. We're going to be viewing, so basically for visualization in Python. Okay, so that's the module for that. Okay, and we use this to save our model. Okay, save our model. So if you're into machine learning, you want to deploy your model, it doesn't just end on your code. Okay, after we're done training the model, we should put it for production for deployment. Now there are also other packages that I'm going to install. I'm going to import from scikit-learn. From scikit. No, from sklearn dot. Now come to the model selection. I'm going to import. Now I'm going to import a lot of packages here. I'll import the stratified k-fold. I don't know what's happening. Just a second. Okay, I'm going to import the train test. I'm going to import the train test split. So what we use it, okay, oh, I see where the error is from. This is from scikit-learn, and I wrote import. So all right, so what we use this to split our model during whenever we're going to be performing some kind of cross validation. So that's what we use this to do. Then I'll import the train test split. I'll import also the cross validation score, because we're going to use it to perform only single metric cross validation, right? Probably whenever you want to use this method, you want to evaluate only accuracy or probably only your precision, ROC score, F1 score, you use it then. But we also have the cross validate method that we use to split several metrics at the same time. So instead of using just this for one single metric, we can use the cross validate to evaluate several metrics. All right. Now I think that's just going to be that. Then we also import the grid search. Okay, so we're using that to perform hyperparameter tuning. Now from sklearn.preprocessing, we're going to import standard scalar and also maybe robust scalar. We might need that as well. We might also need the one-hot encoder. All right. So now what do we use this for? We use this to scale our values, right? Now, take for example, you might be working on a machine learning model where you have age. Age probably is maybe somebody is aged 80 and somebody else is aged. Somebody else has a weight, or sorry, a height that is 1.8. Now, using your domain knowledge, you already understand that this is what you know, that this is for height and this is for age. But what the machine learning model might want to have the values between the range of 0 and 1. So this is the simplest example that you might actually get about how scaling is performed. So what this particular method here does is that they help you in scaling all your numerical variables. Like they help you in preprocessing it in a given scale, right? Such that none of them is noisy during your machine learning training. So that's what we do during preprocessing and other things as well, like one-hot encoding, ordinal encoding, all of that. Okay. I'm going to import the input. I'm going to import from this. I'll import the column transformer from sklearn.impute import simply impute. All right. So what we use this to do now, we'll use this during our column transformers. Whenever we'll be performing column transformers, particularly for some parameters, or maybe if there are some kind of categorical variables that are inside of the data set. So it uses what we call the most frequent to assign them into numbers. because we're not going to be putting categorical numbers or categorical data types into our machine learning model. So from sklearn.compose, compose, I'm going to import the column transformer. So that's the column transformer, that's the particular object where we are going to pass in all the variables for maybe scaling and all of that. So now I think that is going to be that. Then the next thing we'll go for our model, and from sklearn, so we're going to be working like today I said, we'll be using the tree model, right? So import decision tree classifier, and so that's an algorithm. Then from sklearn.assemble, we'll import the random forest classifier. Now these are the two models that we're going to be using for today, okay? So we're going to use them to train the data sets that we've gotten. Then when we are done training these data sets with this model, then we'll now check for the best model, best performing model. That's what we're going to save here. So this is what these are models. Now it's not just okay to import your everything we have here now. We've got, I'm just going to separate this now. Here we have the models. Here we have what we use for pre-processing and cleaning and all of that. And then we'll have basically visualization tools, what we want to use to save and all of that, okay? Mathematical operations, handling our data set, our data frame, and all of that. So you see that all of this are actually properly classified for anybody that's getting started with machine learning models. So basically, this is machine learning for everybody, all right? So whether you're a beginner and all of that, I'm definitely going to make sure I break it into concepts. But the whole idea now is that we want to train a data set that we want to feed into the computer, and then it will be able to make some kind of predictions about type 2 diabetes, particularly when we visualize the data set. Now, what are now the metrics that we're going to be using for judgment? Now, from sklearn.metrics, which I'm going to wrap them inside the list, we import the confusion metrics. Right, okay, I think I have to I didn't add the import confusion metrics. Then we'll import the accuracy score. We import the we don't need the precision recall and precision score. We import F1 score. Okay, what else would we need? The classification report, and we need our ROC curve. We need our ROC score, particularly if, now what I'm going to explain what all these things works for, okay? So don't worry. And then the next thing is recall score. I think that's all. We are good with all of these metrics. So let me explain. Now, whenever we talk about the confusion metrics, now let me just show you something. I'm just going to zoom out from this, and I'm going to create a random sheet. Okay, we're going to open something. Okay, so we're going to call this our machine learning exercise book. Okay. Sorry, I should be using a paint, maybe probably a slide with a kind of writing material, but definitely I'll get that. Now, okay, yeah. So I'm just going to show you something now. If you're somebody that has a background in maybe probably in public health or whatever, I'm sure you should have seen something like this. You've got something like, let's say for example, true positive. You should have heard some of these terms: sensitivity in epidemiology. Okay, and then you have heard of specificity, and yeah, some of that. Okay, so we're going to call this true negative. This is going to be false positive. This is going to be true positive, and this is going to be false negative. Let me just take out this. Sorry, I think I just want it to be okay. Yeah, I think this is okay. We might call this, okay, let me add that back. I'm just going to call this merge predicted. Okay, and then maybe let me me just call this actual something. All right, so I think we'll leave this. Now, this is something I'm just going to zoom in. So I'm just going to zoom in, okay, for you to see. So now what is confusion matrix? Now, each time you run a machine learning prediction, right, and use the confusion matrix, that's just like we've listed here now, to perform your, maybe to evaluate your model, a model. Because basically what we are talking about right now is that we are talking about feeding in information, training the model, right? Training the computer, asking the computer to learn on the data. Then we will now give it something to predict. We will now use some metrics to evaluate it. And those metrics for evaluating how best our model is performing are some of these that I've listed here. Now, what the confusion metrics entails is that the true negative now means how many people did the model accurately classify to not have a certain condition. That is what. So this confusion matrix here returns an array. It's going to return an array, a two-dimensional array that is going to look like this. Okay, so this is what it's going to look like. Okay, now what is false positive? False positive are how many people did the model predict to have the disease, whereas it don't, or have a condition, whereas it don't. Now, this part is what we call false negative. The people that the model predicts not to have the disease, whereas they have it. And this is a very dangerous part. Because think of it, use your intuition. You imagine a model predicting somebody to not have the disease, whereas the person is carrying the disease. It's even better to have the disease, not have the disease, and the model predict, oh, that you have it, and you're just playing with the drugs, whereas that you have it, and the model will say you don't. Now, what's true positive? The people that were accurately predicted to have the disease, and that's what that's going to lead us to accuracy. Now, if you look at some of our metrics, now we have the accuracy, and this is the mathematical function here. We have Tn plus Tp, okay, over Tn plus Tp plus Fn plus Fp. So this is what our accuracy means. Okay, I'm going to zoom that in. Now, you might ask me how about the precision. Now, precision, how to calculate it normally without even this, all right? Is that from here? If we only print your confusion metrics, how to get our precision now? Precision now is each time the model predicts somebody to have a condition, how accurate is it? And that is from here, because this person is predicted to have it. This person is also predicted to correctly have it. So it means that what our precision is going to be what our TP over FP plus TP. FP, sorry, I'm misspelling right now. Okay. So this is our precision. Now, what about our recall score? So our recall score now is how many people was the model able to correctly classify to have the disease correctly, and that is here. That is here. Because this person has it. This person correctly has it. But the only problem here is that this person was predicted not to have it, right? Whereas the person has it. So that's why we're going to have TP over TP plus Fn. Okay? So it's going to... Okay? Oh, sorry. Okay, so this is machine learning forward. So what's your sensitivity? Basically is, 1 minus your accuracy and all of that. So all these things are just parameters that you use in machine learning. So substituting your accuracy with your precision. So we're not interested in this. This is just an epidemiological time, but for machine learning, this is what we're interested in. Okay. All right. So we'll go back to our note. Now, all right. So guys, we are ready. We have all our dependencies installed, and I think we are ready to code. And the first thing we're going to do now is to read this data frame, this particular data set. We're going to say df. I was going to use an object-oriented programming style to wrap all of this in classes. But I don't want to really complicate it so much. I want to make it very simple for beginners, because you still need to understand object-oriented programming. You need to know how to write functions. Those are actually very important. But I'm just going to leave the whole code naked without wrapping them in classes and objects. So we're going to do pd.read. Now, you see, I typed read what? CSV, read Excel. Now, this is an Excel sheet, all right? So this is an Excel sheet, okay? So I'm just going to type Excel, then what's the Excel sheet? I could say sheet name is type 2 diabetes mellitus, okay? And now let me just pass this. I could just rename, copy that, paste this dot XLSX, okay? Okay, that's it. And okay, so let's check the data frame to be sure that the name T2DM that's the name is not defined. Wait, I'm just gonna shit. Wait, sorry. Okay, wait, hold on. I don't know why it's not. Shit. I want to make sure it's reading that sheet, because that's the first sheet. So you can check here. You see that's the sheet here. That 2DM. And you can wrap that in there. No, it's already. Wait, sorry, I'm having two sheets now. Okay, alright, so that works fine. So this is the name of the sheet. So this is how we got it. Now, in this Excel sheet, you can actually have multiple sheets, right? Okay. Alright, so what we're going to do now, df. Now, what we mean by df now is, now let's see what the data frame looks like. So this is what the data frame looks like. Now, this is exactly what we have here, right? So I'm just going to scroll so you can see that, okay? All right. Now the next thing we're going to do right now is we can do df.head. I could do df.head. Okay. So what df.head does is that it just prints out like kind of the first five rows of my data frame. Okay, I could do df.tel. It will give me the last 5 rows of my data frame. All right, and yeah, that's just basically it. Very simple, very okay, and all of that. Now I'm going to show you something now. You see, okay, hold on. Now you see, when we visualize these data sets, now the first thing we do in machine learning, because when we look at this data set, now you see that if we do df.isNull, that what we mean by this now is there any null value inside of it? Then I'm not putting the dot sum. Now you see, it's telling me that there is what? There is no null value here, whereas there are what? Null values inside of this, right? So what I'm going to do now is I'm just going to replace. Okay, I'm just going to come down. Let's leave that probably for our code to be readable. So I'm going to say I'm going to replace that some of those asterisks probably that they might have entered inside of the data. We replace it to np.nan. So what np.nan means is not a number. not a number. That's how you represent it in a data frame. Or maybe let's say you go into the field and the person rewrites comma or duplicates and all of that. Basically, you're going to do what's not a number. So I'm going to do df is equals to df dot rename. Okay. Now, basically, what I want to do now is I want to rename all of this. Like, I want to rename all of this. I want to replace all of this with not a number. I think I'm just going to use replace instead of rename. I'm going to use replace. Then I'll pass this and I'll replace it with np.none. Okay, so now watch. Now let me now run that code again. df dot is now. Let's say is now. Then dot sum. Okay, I'm gonna shift that. So dot, maybe let me sort it so you can see it. Just sorted. Okay. Now what you're going to see now is that you see that it has now changed. So it means that there are no values inside of Plasma. There are no values inside. Now basically what's this data set about? I think I'm going to define what this topic is all about, because when we look at the data set here, we have hypoglycemic agents, and we have some other parameters like smoking, comorbidities, agents, and then at the end of it now, which is our target, we have hypoglycemia. So this is just a model. We are trying to develop a model that predicts the risk of hypoglycemia. Okay. All right. So we just want to predict the occurrence or whatever of hypoglycemia using this particular data set. And now we've now replaced all our NA with this. And the next thing we're going to do now is, now if you understand all of this is pandas, right? From here, we are still working with pandas, PD. We use PD to read it, load the data sheet. Then we are now trying to clean it. First thing we've done is that we've changed the backslash to np.none, because this is rubbish, and it's easier for us to process these particular parameters here than leaving it in maybe whatever. Now usually our patient column, now we're going to drop some kind of irrelevant columns, right? If you look at this particular data set, we have patient number. It usually has no influence. Okay, this is just like kind of a case file report in the hospital. We don't need it. Okay, so what we are going to do now is we're going to drop that. I'm going to be typing my data frame from time to time so that I'll be very close to it. Maybe I could just do something like df.head, and then maybe probably I could just do df.head.form. Okay, something just very simple so we can see it. Now if I want to see all my columns, could df.columns. Okay, now this will automatically show me the column names. Okay, although they look messy, I don't really like how these columns are. I just want something very short and simple. Of course, definitely I'm going to show you how to change that. Okay, now another thing we're going to do now is we want to now have a kind of information about our data frame. All right, so we do df.info. So it tells us how many null counts we have in our data frame. So 109. In short, the first thing we should have done is df.shape to see how many rows. We have 109 rows and we have 33 columns. Okay, 109 rows and 132. So what I mean by that is we have 33 columns across when you go horizontally, and then vertically for the rows excuse me, we have 109 patients that we want to use their data to train a machine learning model. So okay. Now, by the time we drop some columns and all of that are irrelevant, it's definitely going to reduce. So we're going to do something like df.drop, and this is the drop method. Okay, in pandas, and then we're going to drop some columns, and the one we're going to drop is we'll drop patient number, okay, because we don't really need that, it's not really relevant. And I'm just going to put it inside of wrap it inside of a block, then I'm gonna put that. And just to be sure, what I'm going to do is I'll return back to, I think I can delete this. Yeah, okay, I'll just copy this. Yes, just to make sure. I just like to copy that from, so that there won't be room for error. Okay, so automatically I've dropped it. You see that it has gone and it has disappeared. So I'll assign this to our data frame. I'm gonna assign it there. So each time I call df now, what's the problem? This is this. Okay, so each time I call the data frame, the patient's number is already out. Okay. So now the next thing we'll do is df.describe. Remember, basically everything we are doing here now is just to have some kind of visualization of what is contained in our data set. And okay, so what df.describe does is that it shows you, these are basic statistics. Remember, like I said, df.describe, what it does is that it shows you the count, the number of items you have. There is 109. You see 109. Remember the shape. Okay, so we are seeing some of them here that is 59. So this means that there are some missing values here, right? Because you don't just want to get a data set and feed it into the machine learning model. It's not even possible. It's not going to happen. So what you must do is you must have to go through it, look at how the data set is, do some cleaning, do some preprocessing before you now feed it into the model. Because if you feed it into the model that way, it's definitely going to be a very dirty data set. Okay. And so this is df.describe. So it shows some kind of now what we mean for the max is the maximum values. Sometimes you can find outliers from here. What do we mean by outliers? Let's say, for example, here we have age 60. Somebody filled age of maybe 200. It's a mistake. Yeah, you might assume that to be a mistake. So that's an outlier, right? It's outside of the range. We also have data visualization tools like box plots that we can use to visualize them. Probably we have weight. Yeah, I don't think there might be from some outliers because I have girls that are waving. And we have smoking, then we have duration and all that. So what this is a method, okay? And this is a method. What this method returns is that it shows you all the quantitative data in the data set. If there's a qualitative, if there's a categorical data set, like take for example now, this, okay, let's look at this now. Something like, let's have a look from here. You see something like diabetic microvascular complications, acute, blah blah blah, all of this. You see that these are basically categorical variables, right? So it's not really going to be shown on the data. It's not going to be shown when you use the describe method. Only the numbers that are numerical. All right. Even our target here is not going to be there. Okay. Oh, sorry. I'll get back here. Okay. I think I can close this terminal. Okay. Yeah. So the next thing we're going to do right now is since we've got our describe method, now we might have to start drop other further irrelevant columns, and like df, for example, df.head again. Let's look at df.head, maybe 2. Now you see that this particular column here, none, right? It has just one particular, how will I put it? It has one particular item inside of it, so it makes it not relevant. And for the sake of this video, I'm also going to drop some of these categories, right? Some of them like comorbidities that has multiple inputs here, because I wouldn't want to be discussing tokenization, how to read probably text classification and all like that might be too complex for the sake of this video. I just want to keep it very simple. Then I'm going to drop the acute diabetic complications. I will drop this as well. I will drop this. I will drop this and also drop this and this. Okay, for all of them that have multiple like kind of text. Now, if we had something like kind of a binary classification like drinker, non-drinker, it will be easier for us to explain how we can do some kind of one-hot encoding. And now when you look at this particular heading here, type of diabetes, it's not really relevant because it's just the same thing. So there is no, it doesn't have any influence on the data, okay? So I'll definitely drop that. Now, how do we check out if without looking at that data, without looking at this particular CSV file here, how are we now going to know if we want to drop it? So we can do something like df dot. We'll do now. What we can do now is we can do df dot unique. Now, take for example, we want to use this particular part, right? df type 2 diabetes, because that's the, so I'm going to wrap it there. So say dot unique. So this is a method now to show us, so it has only type 2 diabetes. Now let's check out for maybe which one now is going to be, that's going to show us okay, let's use this. Okay, so I'm going to df, this is our target, okay, dot unique. So you see that it contains an array of what? Yes and no inside of it. And yeah, so those are actually those. So what we'll do now is we'll have to rename some of these column names because they look so messy. So what I'm going to do is df dot columns. Okay, so I'm going to assign that to df dot columns. Okay, and the dot is going to be as type string. Type string dot string dot lower. So these are methods. So when we do string dot lower, take for example, now let me explain this now, right? Let's say name is equals to David now, okay? So there you, so somebody will understand. Let me say print name dot upper, for example. Wait, sorry, there's a mistake here. I'm supposed to assign this as a string. Let me just leave it as David. Oh, sorry, what's the problem? Name is equals to this. Okay, mistakenly put an arrow. Now, are you there? Now, this is what it is now, right? So this is what we are saying. What we are saying now is whenever we say df.columns, it returns an object. Like it returns an object that contains list. That's kind of an object index of the list. Look at it here, because when we said df.columns, right, this is a list, okay? It returns a list in an index, okay? Yeah, you can even say dot to list, okay? Maybe if you like. Okay, so you can use this as well, dot columns dot to list. It's still the same thing. What it's going to do now is going to return a list of all the names in the columns. So that's what I mean now. So if you look at this now, name is equals to David, and you say David dot upper. If I say David dot lower, right, it will return. Okay, let me just change it to. Let me just change the. Wait, sorry, I'm gonna change it to David. Then I'll print David dot lower. Automatically to convert it to this. Now let me say I give a space here. Now let me say David dot lower dot strip. Are you seeing it? Now actually it doesn't respond to the inner line, but if I give that space here, maybe okay, and I run it, you see, it brings it inside. So it takes off all these what spaces. That's what the dot strip method does. So we're going to say dot strip for all the by brackets there. I think that's why that was highlighted. Dot strip. Okay, so I'm going to, that needs to pass through a string dot strip dot strip dot. So this is going to be dot replace. So now what are we replacing? We're going to replace any bracket. I don't want to see this bracket. I'm going to replace it with, I'm just going to replace the brackets. I'm just going to take this out with nothing. Nothing is going to be there. So it will just remove this bracket now and close up all these spaces. Now how I'm going to do that is, now there's something we call regex, because if you don't put these regex, these things here now might have a different interpretation. It might change to something like maybe $sign and all of that. So it's best I'll pass this method regex equals to false, then dot string dot replace. I'm going to replace this. Okay, I'm going to replace it with nothing still, and regex is equals to false dot string dot replace. Then if there's a space inside, let me use a double. Okay, if there's a space, replace it with underscore. So by having something like an underscore, we'll definitely see that. And regex is false using dot string dot. I think I found a kind of a slash inside of this. Yes, I think I found it here. So I'm gonna take that out. I found a slash inside of it because people okay. And I will just look at it and probably this equal to, or I can leave that there if you want to replace, that's fine. I think that's that. Okay, so dot. I do want to replace with the equal to. Let's just replace it with underscore. Regex equals to false. Okay. Okay, so we'll do df dot columns. Let's check. Now you see that it has now changed the data frame, that has kind of adjusted it, right? And yeah, so that's how it works. And yeah, so we don't have it's not looking so messy and all of that. So I think I can just delete this. Okay, so that's Python string. Now the next thing we're going to do now is, now since we've got our X and our Y, now we have our gender here as male and female. I think it was here they said female is 1 and male is 2. I think I can change it back. Let's change it back. Okay, let's change it back to male and female. Okay, so whenever we perform some kind of one-hot encoding, it will be easier. Okay, so we'll change it back. Okay, and I'm going to change. How do I change it back? I'm just going to copy this. Or okay, we can change it back now, but then okay, let's just change it back though. Map. So use the map method and pass a dictionary inside of it. Then we'll see what does it have? What does that data frame have? So it's saying that we have 2 is male. Okay, no, 2 is male and 1 is female. So we can just come back here and we'll say for every 1, let it be female. Okay, and then for every 2, let it be male. Okay. Okay, so that's it. So we've changed it. Okay, so if we do df So you see that. Okay, I think one was converting to null. Let's go with that. Just what we are going to do is not a number, so if we do df, okay, we'll take it back so that so we restart this kernel. So once we are done doing our encoding, we'll map it back. Okay, so yeah, we are good still. Now the next thing we'll do right now is, since we have we've unpacked okay, all right, yeah, that's fine. Yeah, we still got that. So in order not to have that NaN value there, because that's like each time you use the map method, it automatically converts it to NaN. What we are going to do right now is we are now going to rename our columns, right? We're going to rename our columns, okay? So I'm going to do df is equals to df dot rename, okay? Then our column, so that we can actually have a much more clearer view of what we are doing. Now I'm just going to copy all of this. I don't want to waste time. I'll copy everything inside of this list, and then I'll paste them here. Okay, all right, so I'm just going to have this is going to, now it's inside of a dictionary, so this is going to be gender. Okay, so I'll be taking it one by one. So the first one is gender. Yeah, I think, okay, that was a mistake, so I'll have it here, but that's correct now, that's fine. So the next one is age in years. So I'm just going to convert that to a dictionary. So use the colon, and it's going to be age, and height in meters is going to remain height in meters. Okay, I'm not going to change that. And for weight in kg is going to remain. I'm renaming the columns now, so this time around that's going to be very easy to handle. And then also which other one, BMI here, we just need a very simple word, not much complication, so we're going to say okay, I'm just going to wrap it in a string, BMI. And then I'm going to have smoking pack history, and that's going to be smoking. Okay, now the next one, okay, that's okay. The next one is alcohol drinking history, drinking, non-drinker, blah blah blah. I'm just going to keep it as what? Alcohol. Okay, now the next one is type 2 diabetes. Type of diabetes, definitely we'll drop it. So I'm not going to touch it. I'll leave it. We'll drop it. Okay, I think we'll drop it. So anyone we're going to drop, we don't even need to, you know, like kind of stress about that. But yeah, maybe I could just say, because it's here, I could just say type. Maybe you can decide to just maybe probably leave it. You might not want to title it anything and all that. It's definitely going to work, because what this rename does is it picks the column that you've selected and renames it. So even if I remove that, that's still fine. Okay, I think I can even remove it there. So I will now quickly assign this as our features, then do our preprocessing inside of it. And yeah, so now the next thing, but I would like to show you how to drop. Okay, no, let's leave it. I'll still show you how to drop it. I want to show you how to drop it. So I'm just going to put that to DM. Okay, that's a static method. So if you're an aspiring data scientist, So this is going to be maybe duration diabetes. Okay, I just want the name to be simple. I don't want acute diabetes complication. We'll still also drop it. Acute diabetes. But I've even dropped it some before coming here. So let's make this thing so much big. Okay, we'll drop them. Then so this is diabetes MC. Let me just title it diabetes MC. Then we have diabetes whatever blah blah. Which one is this one? Another MC. So we're going to call it okay, so now it has to be a string diabetes MMC. I'm just calling it MMC. Okay, I think that's fine. That works better. So comorbidities as well, we'll drop it because it contains multiple strings. So call it comorbidities. Okay. Then the next one is hypoglycemia agent. We'll also drop it, and it contains hypoglycemia. I'm using agents, right? Agents. Other agents too will be dropped. I think that's the last one that we are dropping. So we call it other agents. Okay. All right. So now the next one is going to be. Remember, we're trying to predict the heart risk. That's for as a result of diabetes, and we're going to have fasting blood glucose, whatever. So we'll do it FBG. Okay, so I'm going to wrap it in a string FBG. Right? That works fine. That's very good. Okay, fast FBG. Okay. Then the next one is postprandial plasma glucose. Okay, we've seen that. So we'll call it PP. Wrap it in a string PP. And maybe we'll call it PPGM2H. Okay. Yeah. Then the next one is fasting peptide. Okay, so we'll call that one. What did we call this one? FCPP. Okay, maybe we'll call it FCPN. Okay, anything. I'm just looking for a kind of short name that is going to be easier for. This one now has PPC, so we'll just So you need to have domain knowledge too. Okay, domain knowledge is also very important in mentioning, so that you won't drop PPC. Okay, PN. I think this works well now. So which other thing now? Wait, no. Please, what is this one? Fasting, what? It's fasting IP. So sorry guys, like we need to get the names correctly, and very important because they play a very massive role in the prediction. So I could just call FIP, fine, works fine. And there are a lot of names, oh my goodness. Which one is this one again? This is 2-hour postprandial insulin PMO. So call it. I don't want to give one particular stuff to a name I've given to something. So PPIM. Just call it PPIPN. Okay, all of these parameters are actually important, particularly if you want to perform some visualization, because so this is just simple I'm just gonna keep this simple. Okay, so I'll wrap it in a function. A1C. Yeah, I think that's enough for it. It's quite okay. So the next one is going to be okay. So I'm going to remove that percentage because it's not duplicated. So I'll have glycated. Okay, it's okay. It's okay. So let's go back. So cholesterol, right? Okay, I think the glycated albumin. So I'll have that albumin because I have something that was similar. Okay, this is what happens when I have a lot of column names. So we need to go through that stress of total. Yeah, we can leave this as total cholesterol. It's not bad. We'll do some maybe scatter plots with this cholesterol. Okay, I think that's enough. What is this? Cholesterol. Probably I can't spell. And okay, let me just click here. Okay, this triglycerides. Almost to go through this, you have to. That means most type 2 diabetes people they take a lot is being taken from them. So triglyceride. What's this? Okay. So this is the last. Oh no, not the last. So we'll have high density lipoprotein crossing. So what does the high? So no, wrap it in this high. Then the rest can now be DLCM. Okay, that's okay. Okay. So low density will now be the opposite of that. So low, no, wrap it in low DLCM. Okay. Alright. So if you want to refer back to programming, you can just check your data set program. Yeah, but you have to be very familiar with what you're doing. You name it the way that you're gonna remember. So this is creatinine. That's more than okay. Okay. Estimated glomerular blah 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 filtrate. So do it estimated, then you can now use GFRM. Okay, that's okay. And the next one uric acid. Now I'm gonna do that as uric acid. Okay, I think this last one here, bone. Can just call this one bone. Blood urea nitrogen. Call it bone. Okay, and then the last but not the least, our target. That's going to be hypoglycemia. Okay, so guys, that's it. We've now renamed our columns, and we're just going to run shift enter. That works. So let's check our data frame. That is beautiful. Oh, you see our names are now very, very cool. Okay, so this way we can now drop, play with it. So the next one we'll do now is we need to now drop. So the df drop. So our df will drop columns that have just one. Let's say for example one. Like they are not really meaningful to our data set. Okay, so we'll just say columns. Now there are two ways to do this. I can just pass the columns here as a list. All right, so let me just make it easier for you. I could just do df dot columns. Okay, now here now I want to drop. Now when you look at this now, right, so we're dropping this, we're dropping this. We're dropping type 2, we're dropping this complication because it's nothing is here, it's meaningless. I'm dropping all of this multi-class text classification because we might not really want to go into tokenization and all of that and how to read our text. Okay, there are a lot of non-values here. So maybe I could just say this. I'll just copy this particular method. I'll put it here. And what else do I want to drop? Okay, I just want to check out this. Sorry, other agents and blah blah blah. So I think I want to follow a very good order instead of, so I don't make any mistakes. Just kind of go back. I think I threw this away. Okay, then acute. Okay, I'm just trying to follow this way so that you guys understand what I'm doing. Okay, so what next? We'll go back again to our Excel. We have acute derivatives block. What was this? Okay, that we've done that. This and this and this. So okay, that I think that follows necessary. So just copy it like that, all of them. Comorbidities too. I suspect we'll have hypoglycemic and this as well. So just drop. It's just dropping. It's very simple. Just drop it. Right. Then we'll go back here. I think we don't need. Okay, so we'll take that to agent. Okay, so we are good to go. And all right, so we'll drop. Now I can still work without dropping it. I can just maybe assign my x, then I'll do what we call axis, equals to 1. So this, what this thing means now is that drop is not defined. I think maybe this is not. Let me run that again. Okay, so we need to have here df.drop. So now automatically what this means now is that if we just do df, you see that all of those are out now. Okay, so probably we are now getting having our data set in shape. Now the next thing we might want to now do now is, I think we have some kind of null values right inside of this place. So let us now convert all the, maybe if there are some kind of errors inside of our data frame now, we have to convert it into some kind of how am I going to put it? Let me say, for example, I'm going to convert if there are some kind of nonsense inside of the data. So let's say, for example, now somebody came inside here, right? You see what some people are feeling. Let's say somebody in a certain data set, now instead of this comma, somebody filled unknown in a text. And after we did that replace, we only did it for this because we visualize that it's plenty. But then how can we now, remove all of those nonsense, inside of our data sets that somebody might fill in, or maybe a drunkard was filling out from. Okay. So what we'll do now is, okay, I think I don't want big, I don't want a kind of small head, okay, something that's going to be easy to visualize, so just small. Now, what I'm going to do right now, I'm just going to say df.columns because I've dropped some now, right? So let's see what I'm going to do. I basically, sorry, I don't know why that's not running. So I'm going to take in the numerical variables, the numerical columns, and the categorical columns, okay? So now kind of, let's say somebody filled in none in here also. Maybe the person filled in capital letter N. When we are doing column transform, that whenever we're trying to transform the columns and all of that, we still need to be sure that everything is in line, okay? I can say to string, okay? To string, to list, okay? To list, that's still fine, okay? It works, so that's a very better method. So yeah. So I'm gonna, okay, so let me just go back, please, so I can actually see one thing. Now, so let me now copy the numerical columns. What are the numerical columns that we have here? I'm going to take out alcohol and gender, and I'm not going to copy my columns, of course. So I could just slide this way, and how do we do that? What we can do is we'll do df.datatype. Now what this is going to show us now is going to show us numerical columns. So alcohol is an object. Object here means string. Hypoglycemia, because I'm not going to be manually doing it that way, there's always a mathematical function to do that. Pandas is running on NumPy. It runs on NumPy. Okay. All right. So now I'm not going to take this object and all of that. So basically I already have that. So what I'm going to do now is I'm going to say for course in Let me just create a list and paste all of them there. Okay, I think it will be best practice if I assign this to a list. Okay. Now the reason I'm going to take out alcohol. Remember, I'm going to take that out. Okay, I think that's a comma. Sorry, don't. And then what else? Float alcohol object hypoglycemia. Is hypoglycemia hiding anyway? Okay, I never copied it actually. I stopped at bone, and that's why I have that comma here. Okay, so I'm just going to take that out. Any other thing? Basically, we have all these parameters. You need to know what they are. Yep. So these are float, numerical, integers, numerical. Gender seems to be integer. Why? Okay. Oh, we already changed it to integers, right? No. We haven't changed it. Okay, yeah, we wanted to change it back to numerical. So to categorical, right? And what we will do here is I'm just going to say df. I think I have a better data frame now because that was one of the things that shouted at me then when I tried to change that and forced everything into and so I think I'm going to map it right now. Let me just map it here before we go ahead. So I'm going to do df. So it's smooth now. Wow, gender, and I'm just going to assign that to the data frame of gender dot map. Then I'll pass my list, and I'm going to say maybe that's going to be 1 is male. All right, I think that is okay. No. 1 was 2 is for male, and then and 1 is for female. I think I'm just gonna say female. Okay, that should work. Okay, let's run this. Alright, gender. Okay, it has changed. Okay, yeah. So we run this, and automatically it changes to an object now. Okay, so gender is now an object. There is a reason why I will still change it back. All right, I'll still map it back to this, but I just want to make it very clear. So these are actually what we have, and I have that. This I'm going to say for. Where is a for loop? So for calls, for call in numerical. So in numerical calls, then let's have kind of df call equals to pd dot to numeric. So I'm just going to force all of this to numeric df call, then errors as course. Okay. All right. So what this does now is, I don't know why this thing came out here. So what this does now is it forces everything to become a what? If there is any number that is maybe any rubbish inside of the data frame, it changes it to what? Automatically it changes it to a MPN, not a number. Okay. And what the next thing we're gonna do, and so since we've done that for that, so we can actually do some kind of visualization. Now let's do some kind of visualization. I think we should kind of do some kind of visualization, like we can do for age. Probably we'll have BMI, we'll have height, we have. So what we're gonna do now, let's do for hypoglycemia. Okay. That's hypoglycemia rate, so we can do for hypo. So df So it's going to be equal to, I think I can just so I'm just going to do df.hypoglycemia dot map. Okay, then I'll have yes. Some people filled in yes. Let yes be 1 and let no be 0. Okay, then I'm going to do df. Let me copy this. It's come too easy to copy anything. So I'll do df.hypoglycemia. Then is equals to PD. Okay, I'm just going to numeric. Let me just kind of PD to numeric. Then I'm gonna pass. Okay, sorry. Wait. I'm gonna pass this inside of this. So we'll have errors as equals. Okay, so let it change any kind of error inside of that. So I'm going to still pass it again, df to numeric. Then now this time I'm going to do maybe let me probably, I think once we have this we can drop the NA, so we can say df now is df dot drop NA. So if there are some kind of missing values inside of it, and we can just say columns. I think that's fine to use subset as maybe hypoglycemia. Okay, so let me just want to spell that correctly. Okay, so that runs fine. So df of hypoglycemia is equals to df of hypoglycemia. I'll type int as int. Okay, so what this does now is going to return a data frame that contains 1 and 0. So let me check it. And I can just run that on a new cell. Dot value. Let's also kind of the value counts. That's the problem. Okay. Okay, I'm just gonna run all of this to be sure that works. Probably it's okay. It's running. Alright, beautiful. So yeah, it shows us that we have 0 people, right? People who have maybe who don't have hypoglycemia, and 99 people who have about 1. If I have done this before, you see that after casting this as after mapping this to it turned to what? It turned to a float. So I have to cast it as an int. Okay. So let's just perform some kind of visualization. I think I have to do that. Visualization. Now to do the visualization, so I'm going to do df. I'll put the df of that. Let me just copy that. Df. Okay. Dot. I'm gonna do some dot value counts. Okay, and we'll do dot plot. Maybe kind equals to bar. This should work. Plot dot plot. Plot dot the title. We can say distribution of hypoglycemia. Okay, then plot dot x label. Now what I mean by the x label is the x-axis. Okay. So what's going to be the x label? Probably it's going to be, now this is 0 means maybe you have hypoglycemia, right? Then maybe no 0 means non-hypoglycemia, for example, then one might need hypoglycemia. So we can just say hypoglycemia presence. So I could just close that. So I don't know, I can't spell. So this is now, maybe you have 0 is going to be equals to none, will be maybe non-hypoglycemia, and 1 is going to be equal to hypoglycemia. Okay, we can plot that y label, so that's going to be, okay, so we have the distance, so that's going to be the count. Okay, and plot dot show. Is there another thing that we're missing out on? We can just plot the show. Let's show. Okay, what did it say? It has no attribute of value can. Okay, so it has no. Okay, let's run this again and see. Okay, so what we can do is we're trying to plot this and this. Okay, what we can do right now is we can use a bar, also plot dot bar. Okay, then so we can now pass in our data frame there. Or alternatively, what we can do now is we can say hypoglycemia rate is equals to, or do df of I'm spelling that correctly, dot value count. Okay, so we're just gonna do something like no, this time around, so there's no need, so I can just do hypoglycemia rate dot index. Let's try this, and then I'll have I'm just going to copy this. Okay, I think this is wait, let's try this. It should work. It should work. Beautiful. So this is a distribution of hypoglycemia, right? So the people that have it 0, and it's also very essential in data science. Okay, so we can actually do a kind of visualization for age. You can say plot dot hist, and let's go. We can say plot dot hist, and we're going to pass df dot drop. And you can say df maybe age dot drop na, right? What would that look like? Let's just see. Okay, that works fine. And then we can now set the bins equals to 20, and then we can do, I think we can just delete this thing so that I can have it better. It's just confusing me. So I think we're actually just getting to there. Okay, then so we have plot dot title. So this is where we title the plot. So this is what we'll call histogram showing the distribution of ages. Okay, so it's going to split it into 20, that's bins of 20, and then we can actually have I can add something like an edge color. edge color of, maybe let me put something like black. That's whenever it, okay, I'm just, there's a comma there. I think that's argument is, I don't know why I'm still having that red line there. I wonder what it wants. So we're gonna upload .yx label. So this is the distribution, right? Okay, then plot.y label. So this is going to be the vertical part, and that's going to be the age count or whatever, maybe distribution or whatever. I feel like this is going to be the ages, right? Ages. Then, so this can be the distribution count. Okay, so we are getting the plot dot. What else do we need to have? Plot dot y label, plot dot x label, plot dot show. Let's show it. Now this is what it is. Okay, ages. Okay, this is distribution. This is distribution count. This is the title, and this is the edge color. Okay, edge color is black. So if I change it to white, I think it's more better. It's more better to use white. Okay. Now let's do some kind of visualization for maybe scatter plots, trying to know the relationship between two variables. And that's like here, maybe for example, we can do for weight and BMI, okay, to know the relationship. Okay, so we can use something like a scatter plot. Okay, so just simple plot of scatter. So I could do some plot.figure. Let me do plot.figure because I want to have a fixed size of that's more larger, because if you look at this now here now, and I want to expand it or shrink it. So I could do 5 pixels by 5. So this is going to give me sometimes just for that. It's going to give me an array, right, of 500 against 500 axes. So plot the scatter on scatter plot, and instead of it, I'm going to pass df weight. I just want to be sure. Let me just get my data columns. So df columns, so that I can copy from here. I don't know why. Okay, GNI is there. Well, who cares? I think we're going to drop NA, and I guess we're supposed to drop our NA. But let us wait. I'm just hoping we didn't pass a list here. Just okay. So we have our df of weight, because we can't pass. Okay, I'm just gonna copy that. So we're doing weight against BMI, right? I'm busy copying height. So I'm just gonna remove that square bracket inside there. And then we might drop NA, we might drop NA, but let's run it and see what happens without dropping NA. So what I mean by NA is null values, that's what I mean by that. What's going to be the line width of maybe, don't worry, let's just see what it looks like. Plot dot. Now the first parameter that you pass in here is the X, second one is the Y. Okay, so that's why I say X label. So this is the X label, right? This is the X. So that's going to be weight, and then the plot dot Y label is going to be the height, okay, and then plot dot show. So it's going to show us this now. Now this is a scatter plot, right? So what is okay? I don't think I have a title. I'm gonna put dot title now. So this is going to be a relationship between alright. So now this is actually in more like I can say scatter, not showing. Like I say, illustrating relationship between. Okay, that's fine. I think I can increase this to 8. Oh, that's so long. I'm going to reduce it to 6. I'm going to reduce it. Okay, I think it's fine. So this is, if it's going this way, that means there's a kind of a positive correlation relationship. If it's coming this way, there's a negative relationship. Then if it's kind of scatter, so here we can actually draw a line of best fit, some kind of line that shows the relationship between weight. What's this? This is weight and BMI. Oh God. Between weight and BMI. I must be up to something. BM and BMI, okay? So this is machine learning for everybody, and then the next thing we might do now is, I think we are somehow okay, with what we've got. Basically, we've done our preprocessing. We just want to force this into some kind of scaling. I don't want to pass it through column transformers because if I pass it there, it might. But then we can always show. The only thing we might want to do now is we might need to create our pipelines. We need to define our features. So df.columns. One more time. I'm going to print that out. So these are our features. Okay. So these are our features and targets, rather. Sorry, I don't know why I'm saying features. So I'm going to say features is going to be equal to. Now I will copy all of this. So gradually coming there. I don't know if I performed maybe column transformers, but okay. So okay, just now. What you need to understand now is that our X. Now, what are we doing here now? We're kind of do some feature engineering, right? So these are our features, and then our target. Okay, these are our features. So it means that our X is going to be df of features. Okay. Then I'm just going to use a kind of x, and then our Y is going to be df of what? Probably yeah, it could be this hypoglycemia that we have here, because that's our predictor. So I'm just going to put that in here. Okay. All right, so all of this is sorted out. Now I'm going to perform column transformers, right? Now I could scale this. I could decide to scale this and then wrap up quickly. But then I think I will want to use column transformers because we brought it here, and it will be very fair enough we use column transformers. And then yeah, so because we still have gender. Gender is still in categorical. We have smoking. Smoking is still in categorical. So we cannot just do XY string. No, we can't do that. So we have to pass this through a column transformer. If we want to do some kind of splitting now, we might want to now kind of encode smoking, encode this, then leave it here in our features, then use a scalar to perform that. But I'm going to pass it through column transformers before I will now have my features and targets. So what I'm going to do right now is I'm going to list out what are my numerical features. Everything here, literally, except smoking, which I'm gonna take out. Okay, so these are my numerical features. So I'm gonna take out smoking. Where is that? Okay, so that's it. I've removed. I think there is a comma somewhere, not somewhere. Why is that? Okay, that's it. All right, so I'm gonna have my categorical features. Okay, so these are my categorical features. So what are my categorical features? We have gender, and we have smoking. Okay, yeah. Now remember, we're not going to fit in our y, or we're not going to touch it. Okay. All right, so somehow this might be duplicated or somehow. I'm just going to comment that out. Now the next thing we're going to do now is we're now going to frame our numerical pipeline. So we'll have something like a numerical pipe. Okay, where we'll now say, okay, pipeline. Did we import pipeline? I doubt. Is it there? Okay, it's not there. So from sklearn.pipeline, so we have to import pipeline. So I'm going to run everything so that will work. But I expect it to throw an error that last part because I'm still writing, I'm not done. It's gonna say this is not defined. Yes, pipe is not defined, but it's defined now. So say pipeline, then steps is equals to. Now what are we going to pass inside our pipeline now? Now we want to pass in we want to do some kind of scaling, right? So that's what we call this pipeline. We want to perform some kind of scaling. All right. Now we have min-max scaler, we have the robust scaler, we have the standard scaler, and a lot of them. So but here now we're going to be using the standard scaler. Okay, we're not going to be using the min-max scaler. Now what we'll do now is this pipeline is going to be really very helpful. So we're going to pass in right here our imputer, right? So this is going to be our imputer. Then we're passing the simple imputer and strategy for numerical. That's now what this thing is doing now is because we have NaN values inside of our features, right? Like what I mean by NaN, I'm just going to show you. Kind of just scroll up a bit. Now, let me just come down. Let me come down. Let's just come down. Now let me just open this thing, right? So I'm just open this sound with df.head and maybe put like 6, okay? Now it's going to find out that we have some NaN values inside of this data set. I'm not sure of scale that. I'm just gonna let me just do kind of tell. Okay, yeah, there you go. So you see, these are NaN values, right? Now, what scaling does is that when you have a data set, right, and 49 are not filled up. Let's say, for example, in your data set, 49, like there are some kind of empty columns inside of it, right? Now, what you're going to do now in that data set now is that essentially you're going to, inside of that data set, what you're going to do now, in that data set, for example, now is that, let's say, for example, now you've got some missing values, right? And I just want to give you an example that is best now. Okay, let me just give you something now. Okay, let's say x is equals to 5, 6, 7 mp.nan 8. Now print is now in x. It's going to return true. Okay, what's the problem? Wait, let's print, just print, no, it's next. Okay, let's print X, right? So this is a non-NaN value, right? So this is just like a list. So these are like, when you bring, one list is one series. This is one series. But when you have something like X and you have Y, when you put them together, it's not a data frame, two or more lists. So this is a non-value now. So what this does, column transformer simply imputer does is that it is going to say, okay, how do we now replace this here, this particular NaN? How do we replace all the missing values? We're going to use the median values or the mean to replace it. And that's why when we come to this imputer here, we'll see strategy is equals to what? Median. Okay? That's the strategy to do that. Okay, so I'm going to say comma, we're going to actually put scalar. So we're going to scale it. We're not using a robust scalar. So we're going to use a standard scalar, okay? Standard scale, that's what I'm going to use in that pipeline. So for the numerical features, okay, here, for the, no, not the numerical features, sorry, for the categorical pipe, for the categorical pipe, we will now have pipeline. Now, how do we now replace categorical variables if there are missing? Let's say there is none here. It will use the most frequent, the one that comes most, like the most frequent one. It will use it and cleaning up other one. But we don't try that in our target. We don't try it. We don't try it. Do you understand? Target means that maybe, let's say for example, target is hospital results. You now fill up none with positive. No, we don't try. What we do is we drop all of those ones. We drop it from the data set entirely. Do you understand? So we drop them. So because it's a very key area. Because if you do that, then that means you're bringing the wrong model, because machine learning is more concerned about evaluation, your metrics. Do you understand? It's not even about what is predicting, because everything will predict. It's just the accuracy. Okay, so here I'm gonna have strategy is gonna be the most frequent. Okay, and then I'll then I'm gonna have maybe we could call this 1 hot. Okay, because we're using the 1 hot encoder. I'm gonna say 1 hot encoder, and then we'll have some kind of handle unknown as ignore. So if there's any kind of unknown inside it, use ignore. So we're gonna do our pre-process now. In order to bring this, we're gonna do pre-process. Now we're gonna pass this into our column transformer, because basically that's what we're gonna do. Column transformer, we're gonna say transformers. So here we might call this a cat. Now I can just say, you can say num, and we'll pass our numeric pipe. Okay, that's numerical pipe. Okay, that's it. I'm just going to click on that to be sure. Okay, yeah, it's highlighted that one as well. So because of numerical features and the comma, so we're going to have our cat. So we're going to pass our categorical pipe, and then we'll pass cat in. This is a classification report. Categorical features. Okay, and I think that's that. So that's that for our transformers. And yeah, so basically where's the error from? What's the issue? I thought we sorted it out. Alright, so everything runs fine. So now what we'll now do now is, now we now need to now invoke our models, right? How many models are we using now to train now? Because that's what we want to do. So we're going to be training with tree and decision and ensemble. So, but for now, I'm just going to use the tree method. All right. Maybe let me just use the ensemble, the k-nearest neighbors classifiers to work on that. So I'm going to say, what do I need? I just need to say model. That's I'm going to say tree model is going to be could say this pipeline. I'm going to call another pipeline, again. Then I'll pass. Wait, sorry, just steps. So I'm going to have here preprocess, okay? Preprocess, okay? That's fine. And I'm gonna have what else am I gonna have? Here I'm gonna have the model, okay? So I could call it tree classifier, whatever. So it's going to be decision tree classifier. I think I'm going to just keep the max depth as 4. Although when we perform hyperparameter tuning, we'll still know, understand which seems to be very better. I could call this pipeline or whatever, but maybe if I'm returning pipeline, whatever, but that's fine. So this is the model, and we can fit and transform this. So, but before we do that, we need to declare our x and y. Now we can't use this now because we've already changed something. But one of the best things we can do now is we can do df. What we can do now is we can say our x is going to be df dot drop okay, we can drop to encode this df dot drop columns of what's that? That's gonna be I. Let me check that out. Oh, where is that? That's hyperglycemia, right? Okay, so that's it. I think that's actually getting to the end. So I'm just going to drop this, and then our y is going to be equals to df dot what? No, that's just this. No, I'll drop it in the method. So we can say x dot shape. Okay, that's fine. Yeah, we can do y dot shape 109. Okay, that's fine. Okay, now the next thing we might want to do is since we've got our model and we've pre-processed all of this, I'm just be sure that we are not. So just say x train, x test, y train, y test is equals to train test split, and then we pass in our model dot fit x train or whatever. So it's gonna have x here and y, and what else we need? We need our test score, test size to be 0.25. Okay, that's quite big. The dataset is small. Stratify is going to be y. Random state is going to be maybe 34, whatever number. Okay. Now the next thing we might want to do now is we do tree model dot fit. Okay, so fit it here, x train, y train. Okay, and then next thing we can do now is we cannot do our y pred. It's going to be tree model dot predict x test. Cannot use median strategy with non-numerical data. Oh, what's the issue? Oh yeah, what's the issue? Median pipeline of numerical features. Oh, sorry, we didn't remove alcohol. Well, let me check alcohol. What's alcohol? Oh, it's even smoking. I confuse smoking with alcohol. Smoking, let's be sure. Smoking should be numerical. Let's check out that. Oh, sorry, what happened? Okay, so smoking is numerical, correct. So alcohol is categorical, so that's the mistake. So we need to where is that? So we put alcohol is numerical, right? So we just put that back. Yes, so that should work now. Okay, we're not done. Okay, what's the issue? Said cannot use median strategy with non-numerical data, and it highlighted non-drinker. I think we've changed that. That's the issue. With smoking is numerical, right? Oh, I went to go and put it back. Alcohol is categorical, if I'm correct. Let's check. Alcohol is category. Yes, correct. Oh, then smoking is numerical. Okay, I think that should work. And as far as any other issues, gender, I think that should work now. The given column is not of the data frame. Oh, what is that column? It's not of the data frame. This is where the debugging comes in, and let's check all these things to be sure. Let me just again. Which column? Hypoglycemia spelled correctly. Okay. It's an extra train. Is there any duplicates? Just want to check. You can add our this demo. I'm just checking. Add the demo account. Okay, so the next thing what we can do now is the alternative, what we can do, since we already understand how to use our column transformer. So what I'm going to do now is I'm going to encode these features, and then so I'm going to encode our these are categorical variables using the normal one hot encoder. That's the normal mapping method. Then we will now force everything through our min max scaler, or maybe we'll probably use a robust scaler. Yeah, but then we still need to some kind of remove some what's that some missing values, and trying to check if it's not split spelled correctly. Certified X test. So yeah, that's what we're gonna do now. So what we're gonna do now is, for data frame of gender is gonna be equals to df gender, and okay, that's dot map. Then we'll have our dictionary, and then we'll pass in what do we have in gender? We have female is gonna be 1, and then male is gonna be 2. Now real quick, okay, I think that should be settled. What else is up? What do you want again? It's gonna be 0. Now it's gonna be 1. 0. That's a problem. Okay, these are a dictionary. Okay. Oh, that's not a dictionary. This is not pressing well. Okay, that should work now. Okay, that's good. Now we should have our alcohol. Now what we'll do now is we'll do ddf alcohol dot unique. Okay, let me find out what's inside there. Okay, so I have drinker, non-drinker, and I'm gonna encode it real quick. I'm gonna say df of alcohol. Okay, because the df of alcohol, let's map. Okay, then we have non-drinker 0, drinker 1. Okay, and yeah, that should work fine. Okay, so now what we'll now do now is I'm gonna just comment out this pipeline. Okay, I'm gonna comment it out then, but I'll still pick all of this. Okay, so I'm gonna have, now we have some kind of null values here. So how do we deal with that? Because we're not forcing it into the pipeline. Now what we might do is, because the vast majority of them are already what's that? They are already numerical. Okay, so what I'm going to do now is I'm just going to do for calls, and I'm going to pass a lot of them inside here. Let me take out the column. Is there any smoker? Alcohol is not here. Okay. The page, I think we've run this command before, to be sure. Just to be sure. Drop NA, okay. So So there's actually a lot of ways we can do that. There are so many ways. So what we can do now is we can actually do for calls in this. We can do df. So now watch my indentation. So df dot drop na calls. I'll change this to calls, right? Call for calls in this, in all of this. So it should drop the na in all of them, and start with df is equals to df. So the different text function to again drop na, and what again I'm gonna pass. Like a subset equals to call. Smoking, duration, diabetes, blah blah blah. Okay, what does it want? Okay, I think we can instead of us to use this approach, what we can do now is I think I'm just gonna comment this. Let me comment this pipeline. Then we'll try and fix up the bug in it, okay? Because it's going to really give us some kind of insight into what we can do. So just as we're trying to debug this now with train model.fit, so I'm going to pass. Okay, yeah, that works fine. Okay, so the next thing is going to be y proba. So y probability is going to be true dot model dot predict. Then here we're going to have so for our y probability is going to be predict proba. Okay, so that's the method. So here we're passing our y test, and yeah, what are we against our ground truth, which is our y predict. Okay, and then we're going to pass to this 0. It's going to go to 1. Now, so this is actually how we get our y proper, right? And now the next thing we're going to do right now is we're going to now get our CV cross validation score. So our cross validation is going to be we have that's more like CV is going to be stratified k-fold. Then we'll have end splits as 5. Then we'll shuffle it probably as true. And then we're going to have our random state of maybe 34, whatever. Okay. Then our scoring is going to be in the dictionary. Then I'm going to pass in arrows, arrows. Then we'll have F1 is to F1. Then we'll have our accuracy. So I'm just going to wrap that to the list. Accuracy. And then we're going to have our what else are we going to have? We can have our recall. And then we're also going to have our precision. On precision, okay? Then now what we're not going to do now is to get our CV scores. Okay, so our CV scores is going to be cross-validate, cross-val score. Now we can use one metric. Okay, so we'll pass our tree model x, y, then our x and y Then next one we'll have is CV is going to be equal to CV, which is the stratified key food, and then we'll have our scoring because this is only one single matrix. Maybe we can do ROC use. Okay. Now, because we want to use the cross-validate method, so we can also have three CV results. So we're going to pass our cross-validate. We'll still pass our tree model. Then we'll have our X, Y. Then we'll have our CV as our CV. Then we'll have our scoring equals to scoring. Okay. Now, so this is actually what we need to have, right? And if we want to, now what you need to understand is that instead of this CV cross-validate score, we can decide to say return maybe train score, because I won't want to have a dictionary that contains the train score, only the test score. That's what I want. So this is going to be false. And now to print each of these CV scores, right, I could just say print our CV scores. So I could, now it's going to print the ROC, right? So what's the ROC? Is the receiver operator characteristic. So that's like a kind of curve that shows you how distant are you from predicting positive from negative, because probability returns like numbers that are ranging between, let's say, 0 and 1, right? So let's say, for example, you have 0.20 and you have 0.8. Now it's closer to positive, right, than to negative. And we're taking the first particular, that's the first dimension of the array, the second dimension rather, because it's 0 to 1, so it's going to count from 0 from the beginning to the end. So it's going to only take their last particular array dimension. Now, what this particular ROC scenario, AEUC, means area under the curve. So we can actually decide to calculate the area under the curve. We can try to say our ROC, no, that's not normal Python. Our ROC AUC, right? It can be the ROC AUC of our Y prober. I think we'll pass our Y test, then our Y prober. Okay. So how do you get Y probability? You get it from here. As you get it from here, yes. Okay. So that's when you cross your predicted, your ground truth, which is Y test, with the predicted, that's what you've gotten after you used the model. So that's the return from the pipeline to make some prediction. So this is also another way to get your ROC AUC. Now, but if you want to use the cross-validation, what's the essence of cross-validation? We want to split the method. We want to split the data set into 5 sets. Like we split it into a set, train it, then split it into another set, train it, split it into another set again and train it. Now we'll now get some kind of values that are ranging across a particular given mean. Then we can decide to print the mean, and that's what we can do. You can decide to say, okay, print the mean CV scores. Okay, so that's going to be CV. So that's going to give us that CV scores dot mean. So use the dot mean method. Okay, so we can actually decide to, if we decide to print CV scores, it's going to return a list. Okay, so I'm just going to CV scores. So it's going to return a list CV scores. All right. Yeah, that's what it's going to return. So I took a comma. Okay, that's all I read. Okay, it goes on. Now, what we're going to do right here now is, since we have this particular parameter here for the ROC AUC, because we're trying to get that area under that curve to estimate how, that's going to estimate the distance between the false positive rate from the true positive rate. Okay, and I'm just going to show you what I mean now. So you can just come online now. Let me just show you something. What's an ROC curve? I want to see some kind of ROC curve. Yeah, the scikit-learn. I'm just going to show you what I mean. Now, the reason why I'm showing you this right now, if you're watching this video, is that you want to understand what does the magnitude, the threshold between positive and negative when it comes to false positive prediction, because ROC doesn't take in classification labels. It's definitely going to take in true positives or false positivity. Now, so if you just look at this particular classifier here, you see that this is better, this is worse, because this is more closer to false positive, this, the yellow one, right? Right? It's more closer to what? I'm just going to show you something right now. So you see, the yellow curve here is more closer to the false positive compared to the blue one. So the blue one is more closer to 1. So it means that it's a much more better classifier compared to the green and the yellow. Alright, so I'm just going to show you real quick how we can plot this arrow thing. Sorry, I don't just know why I jumped into here. Okay, so there are also other better curves out there that you might want to use. Okay, then let's jump back into our code. So how we're gonna do this now, we're gonna say false positive rate, okay, true positive rate, comma, underscore, or we can try to use threshold, that's a placeholder, but I want to go for underscore, is equals to ROC curve. Yes, I know definitely my debug. Then we will now pass in our y test and our y probability. Okay, then we can have the plot, then we'll have our now this returns the list, an array, one-dimensional array, right? That's of several false positive rates. Okay, and this also returns a one-dimensional array. So I'm not going to pass the list here, because if I nest the list here now, it's definitely going to work. So I could just put that false positive rate, true positive rate, and then I'm going to now say, I'm not going to say that then I'm going to pass kind of an f string here. Now why am I passing an f string here? Now to put a kind of label, right? So this is going to be maybe I could just say this is the label. Label is equal to this, pass an f string. Okay, let me just punch the round method. So this is like ROC, sorry, I don't know why AUC y test y proper. Okay, and that's going to be 2 decimal places. Okay, so there's also another way to do this. If I don't want to use the round method, I could just remove the round method and put .2f. This is going to work. You see, maybe I delete this now. Let me just delete this. I think there's still another bracket there. Let me just delete the bracket and delete this. Okay, I'm not supposed to delete that. Okay, so this is still going to work, but I think I prefer it that way. Then I have plots dot plot. So I need to plot now. Let me show you something now. I need to plot these red dotted lines. All right, I need to plot it. So this is just like kind of a constant, because the range is 0.5. So this is kind of a random guessing. So we're going to plot that. We're going to plot 0, 1. So that's, I'm going to show you real quick now. Then we'll have another 0, 1. Okay. Now I'm just going to set some kind of line. I think we'll do line dash or something. If I can do this now, I want it to have a dashed line. So I could say line tick. Or what am I? How we're gonna put it? Could say line space. No. Okay. Just a second. Okay. I'm going to see that. Critical tick. Okay, because if we leave it this way, it's gonna be a dashed line, but we can still actually evaluate the metrics there. So I'm going to do plot dots. The title. So plot the title. We're going to have what are we going to have here? So this is going to be the ROC AUC curve for evaluating force positive. Okay, so can plot dot x label. Yeah, please, if you're watching this video, you can just make sure you like and subscribe. And then so the x label is that the horizontal is going to be force so this is going to be true positive plot the show. Okay, all right, so we're going to run everything at once. Now the next thing we're going to do now is we will now need to perform our kind of hyperparameter tuning. So I'm going to run everything at once. Hyperparameter tuning. So we'll start by our model is going to be decision tree classifier. We're not passing any parameter. We have our params grid. Grid is going to be equals to we have our n estimators. Now we're working with decision tree. We have our n estimators, and I could just swap that in the list comprehension I for I in range between 1 and 10. No, we can put it between 3 and 10. Okay, so I think that those are actually some kind of key values that we might need. And yeah, maybe if we want to actually enter other parameters too, because basically what we want to get is the best estimator. And yeah, because we usually have our max width, and we have our, mostly whenever we're working on tree-based model, we're trying to know how best they can fit, through the training and get the very best estimator for our model, right? So we're going to have our grid is going to be equals to, now we pass some parameter here, our model, so it's going to be model. Okay, so this is our model. So if you can actually call this TT model, it still works fine. So we have our x. No, we're not going to have our x. So we have our params grid is going to be equals to params grid. Okay, and okay, I think that was going to be a dictionary kind of. And okay, now I think this is supposed to be a list or something. No, it's going to be a dictionary. And params grid is equals to params grid. And we have our CV is equals to CV. And yeah, so basically this is just something that's going to help us get the very best, um, get the best hyperparameter, that's best estimator for our model. Then we're going to also have, so we can fit in our grid.fit. Okay, so grid.fit is going to be x train, y train. Okay, so we'll now say our best model is equals to grid dot best estimator. So this is actually going to give us our best model. So if we actually start from here now, I'm just going to kind of explain some things, right? So we started from actually matching our numerical features, and then we've got our categorical features as well, all matched in. That's for our pipeline. Yeah, I think basically we just ignored this. There wasn't any need for that because already we've got everything fitted into our pipeline. Then we'll have our numerical pipeline, right? We've got our categorical pipe. Then we use the one hot encoder to handle it. And yeah, so that was basically for all our categorical, variable features or whatever that we did, declare. And then we now went into our pre-processing here, where we now framed our column transformer, our transformers, the norm, numerical pipe, which is this, numerical features, and that is that there. So we've got our categorical pipe, which is this, and we've got our categorical features, which is also this. Okay, so we now initiated our tree model, right? And yeah, inside of our tree model, we've got kind of our pipeline, our steps, pre-process, model, decision tree classifier. We've got max depth. Then we've got our X to be dropped. That's why we dropped our that's the hypoglycemia in a column, and then we've got our Y, where that's for the hypoglycemia column. Basically, that is what we plotted somewhere up here, where we try to show some kind of, distribution between hypoglycemia and, yeah, that's kind of distribution because we've got, people who are identified to be 1 and, 0. And yeah, so all of these are some of the things that we actually performed here, and then we went on to set up our X train, X test, Y test, Y train, Y test, which is train test split of X, Y. Then we'll have a test size of 0.2, stratify Y, and then random state of 34. So we've got a model that fits X train, Y train, and then Y pred X train tree dot model that is predict. Then for Y prober tree dot model dot predict prober, we've got Y test, Y pred until that's the actual last column. Okay. Now cross validate, we use a stratified k-fold to perform our splitting. We shuffled it, and then we also stated our random states because in order not to let our data change. Then our scoring parameters, we've got ROC using receiver operator characteristic using. We've got our accuracy, recall, precision. Then we performed our cross validation here, where we showed our tree model XY CV equals to CV scoring as ROC. Then we've got our true results and all of that. And also we performed some kind of cross validation with our CV scores to get a mean, because it did return some a list of cross validation scores, and we got a mean, and then we got our ROC, where we plotted it to the ROC for the Y test, Y prober, then the false positive rate, true positive rate, to our ROC curve method, and then we perform the hyperparameter tuning and all of that. So definitely we're going to have this code on our Git repository, And yeah, you can always perform a lot of visualization. I think I've tried to cover a lot of things in this particular lecture. And yeah, if you're really looking towards starting your machine learning journey, I believe that there are definitely a lot of things you might want to work on. You need to learn how to perform gradient descent, which is one of the topics I'm definitely going to be getting into. And then I'm going to also do some more videos on how you can tune hyperparameters, particularly for random forest, gradient booster, X boost, support vector machine, and other models that are actually relevant for you to tune. So I'm sure you were able to get the very best out of this class. Definitely, we're going to have our model saved, dropped in our Git repository, and I will definitely see you in the next one. Bye.